we have given function. First, we need to find the domain of our function. We have division. It means we have to check our denominator. Denominator will be 0 for x equals 5. So our domain will be all real numbers excluded 5. Now, to find if our function has maximum and minimum, we need to find first critical points. To find critical points, we need to find first derivative. We have derivative of quotient, so we use formula u over v. First derivative is equal v times derivative of u minus u times derivative of v over v squared. So first we have to just copy denominator, so we have x minus 5 times derivative of numerator will be 2x minus 1 minus, first we copy numerator, now we have x squared minus x minus 12 times derivative of denominator, so is 1. I don't have to put. So we have over x minus 5 to second power. This is equal, we have multiplication, x times 2x will be 2x squared minus x minus 10x plus 5 minus, because we have negative sign before this parenthesis, so I have to change this sign, so we will minus x squared plus x plus 12 over, we have x minus 5 to second power. This is equal, in numerator we will have, we can combine with the like terms, so 2x squared minus x squared is x squared, negative x, negative 10x is negative 11 plus x, so it will be negative 10x, and we have 5 plus 12 is 17 over x minus 5 to second power. Next, to find critical values, we have to set y prime is equal 0 if and only if, because denominator cannot be 0, we only check our numerator. In numerator we have x squared minus 10x plus 17. This is equal 0. We have quadratic equation to solve. We will use formula x1 2 is equal minus b plus minus square root of b squared minus 4ac over 2a. We know that a is coefficient before x squared, b is coefficient before x, and c is our constant. So this is equal, we have b, we have to copy negative sign, and b is equal negative 10 plus minus, we have square root of b squared, so we have negative 10 to second power minus 4 times a is 1 times c is 17 over, we have 2 times 1 because a is equal 1. So this is equal, negative and negative give us positive 10 plus minus, in denominator we have 2 and we have square root of negative 10 to second power is 100 minus 68, because 4 times 17 is 68, so this is equal 10 plus minus square root of 32 over 2. So we can rewrite this, it will be 10 plus minus 32, we can rewrite this is 4 times 8. So we will have 2 square root of 8 over 2. We can divide by 2, so it will be 5 plus minus square root of 8. So we have 2 critical values. We can use calculator and calculate this. X1 will be approximately 7.8 and X2 is equal 5 minus square root of 8. This is equal 2.1 approximately. So we have 2 critical values. Now, to find if we have maximum or minimum for these values, we will use the second derivative test. So it means first we need to find the second derivative. To find the second derivative, we have to find the derivative of our first derivative. This is our first derivative. So it will be, in denominator we will have x minus 5 to 4th power, and in numerator we will copy x minus denominator to 2nd power times derivative of numerator, so we have 2x minus 10 minus, now we have to copy numerator, so we have x squared minus 10x plus 17 times the derivative of our numerator. We have composite function, so we have 2 times x minus 5 to power 1, because 2 minus 1 is 1, and the derivative of expression in parentheses is 1, so I don't have to write this. So now this is equal, because we have x minus 5 in this expression and x minus 5, I will factorize this. So denominator we can copy, and here we have x minus 5, and in parentheses we have x minus 5 times 2x minus 10 minus 2 times x square minus 10x plus 17. So close parenthesis, this is equal. We can reduce 4 will be 3 now with x minus 5. In numerator we have to multiply x minus 5 times 2x minus 10 first, so it will be x times 2x is 2x squared, x times negative 10 is negative 10x, and now we have negative 5 times 2x is negative 10x, negative 5 times negative 10 is positive 15, and we have to multiply negative 2 by this whole expression in parentheses, so it will be negative 2x squared, negative 2 times negative 10x is positive 20x, negative 2 times positive 17 is negative 34 over x minus 5 to 3rd power. This is equal, we can combine the like terms, 2x squared minus 2x squared we can reduce, negative 10x, negative 10x is negative 20x and positive, so we can reduce this, and we have 50 minus 34 is 16 over x minus 5 to 3rd power. We use second derivative test to find minimum maximum. It means when we have a second derivative, we have to calculate now value, the second derivative for critical values. So first critical value is 7.8. So we have second derivative of 7.8. This is equal. It means we have to replace our x by 7.8. 0.8. So numerator we just copy 16 over 7.8 minus 5 to third power. This is equal, let's use calculator. So we have 16 divided by 7.8 minus 5 is 2.8 to third power. This is equal 0.72. We got positive value. It means for 7.8 we will have minimum. Now we have to calculate the second coordinate. Because we have x, we have to calculate the y. To find the y, we have to use our formula, our function y equals. We have to replace x's by 7.8. So we have y of 7.8. This is equal. And in numerator we have 7.8 to second power minus 7.8 minus 12. And denominator we have 7.8 minus 5. This is equal. We can use calculator. So we have 7.8 to second power minus 7.8 minus 12. This is equal, divide by, open parenthesis, 7.8 minus 5, close parenthesis. This is equal 14.65. So we have 7.8 and second coordinate is 14.65. At this point we have minimum, one more time. Why? Because the value of second derivative for 7.8 is positive. So we have point of our minimum. Now we have to check the second critical value is 2.1. We have to check if we have maximum or minimum. So we calculate the value of second derivative for 2.1. It means we have to replace x, because this is our second derivative. This is our second derivative. We have to replace x by 2.1. So numerator is 16. In denominator we have 2.1 minus 5 to third power. This is equal. So we have 16 divided by, open parenthesis, 2.1 minus 5, close parenthesis, to third power. This is equal negative 0.65. We got negative value. It means for 2.1 we will have maximum. To find this point we need to find the second coordinate. So it means we have to go to our formula of our function one more time. So this is our function, and we have to replace x's by 2.1. So y is equal, we have 2.1 to second power minus 2.1 minus 12 over, we have 2.1 minus 5. This is equal, we can use calculator. We have 2.1 to second power minus 2.1 minus 12. This is equal, divide by, open parenthesis, 2.1 minus 5, close parenthesis. This is equal 3.34. 3.34. So we have our maximum point. First coordinate is 2.1, the second is 3.34. This is our maximum. Now we have to check if our function has inflection point. To check if function has inflection point, we have to set our second derivative to 0. Our second derivative formula was 16 over x minus 5 to third power. So second derivative is equal 0 if and only if we have 16 over x minus 5 to third power. This must be equal 0. On the left side we have fraction. The numerator cannot be 0. So we have to compare only numerator. We have 16 should be equal 0. 16 is different than 0. It means we have no inflection point. Let me write this. No inflection point. This is my solution.